Hi, and welcome to day 9 of Rational Expressions. We are solving word problems leading to rational equations. This is my second attempt at doing this. That's why all the writing is already there, because I wrote it, did the video, and it did not save the video. So I decided to just talk you through the problems instead of redoing the whole thing, since it took me a while to do the first one. So if this is difficult for you to follow along with, you won't be able to write as fast as I'm talking. So you're going to probably have to hit pause while you're watching the video so you can copy all the stuff and just listen. Um, for the first problem here, Anne and Maria play tennis almost every weekend. So far, Anne has won 12 out of 20 matches. How many matches will Anne have to win in a row to improve her winning percentage to 75%? Well, they've played 12 and Anne has won 12. They've played 20 matches. So in my fraction here, this 12 and this 20 are the original games that they played. If she wants to improve her winning percentage to 75%, then they're going to have to play X more games. So I'm going to add X to both the numerator and the denominator. And the 0.75 is 75%. What I did is I multiplied by the LCD, which was 20 plus X on both sides. So after I do that, on the left, they cancel out, so I'm left with 12 plus X. On the right, I have 0.75 times 20 plus X. Then I need to distribute that 0.75, and I would get 15 plus 0.75X. Then I subtracted here the 0.75X on both sides. And I had to come up here to write the answer because I didn't have enough room. So it's 12 plus 0.25, it's a 0.25, is equal to 15. Subtract 12 from both sides, so 0.25x equals 3. Divide both sides by 0.25, and I have x is 12. So she would have to play 12 more games and win all 12 of those games to improve her winning percentage to 75%. All right. So Anne is determined to be better than that. So how many matches will Anne have to win in a row to improve her winning percentage to 90%? Well, it's the same problem. We just change our percent. 90% is 0.9. So we keep our 12 plus x over our 20 plus x, and we say it equals 0.9. Again, multiply by 20 plus x on the top and the bottom. On the left-hand side, it cancels out, so I have 12 plus x. And then I have 0.9 times 20 x. I distribute my 0.9, so I have 12 plus x equals 18 plus 0.9x. Then I subtract the 0.9x from both sides, and I will get 12 plus 0.1x equals 18. Then subtract 12 from both sides, so I'll have 0.1x equals 6. Divide both sides by 0.1, and when I do that, I end up with 60, which means they would have to play 60 more games in order for Anne's winning percentage to be 90%. And out of those 60 games, she would have to win all of them. For part C, can Anne reach a winning percentage of 100%? No, she can't, because she's already lost 8 matches. So there is no way Anne will ever be at 100% winning, no matter how many games they ever play. She can get close if she won all the rest of the games they ever played, but she will never be 100%. So for part D, after Anne has reached a winning percentage of 90% by winning consecutive matches in part B, how many matches can she now lose in a row to have a winning percentage of 50%? So they have the original 12 games plus the 60 games that she just won to get to 94%. So that gives her 72 games. And then they played 20, and they had to add that 60 more, so we have 80. So I have 72 out of 80, and I am not going to win anymore, so I don't add anything to the numerator. I'm only going to add to the denominator, so I did 80 plus y. So multiply both sides by 80 plus y, and you get 72 equals 0.5 times 80 plus y. Distribute the 0.5, so 72 equals 40 plus 0.5y. Subtract 40 from both sides, so I have 32 equals 0.5y. Divide both sides by 0.5, so I am left with y equals 64. So she could now lose the next 64 games after winning the last 60 and still have a winning percentage of 50%. That's an awful lot of tennis. All right, moving on. For example, number 1. Working together, it takes Sam, Jenna, and Francisco 2 hours to paint one room. Let's see. When Sam is working alone, he can paint one room in 6 hours. When Jenna works alone, she can paint one room in 4 hours. Determine how long it will take Francisco to paint one room on his own. Well, we're only talking about one room, so that's the numerator. The denominator is the time that it takes them to paint the room. So my first person was Sam. And Sam, it took him 6 hours to paint one room. And then Jenna, when she works alone, she can paint a room in 4 hours. And Francisco, we don't know how many hours it's going to take him to paint a room. But we know that when we add them all up, it takes them 2 hours to paint the entire room. So this is everybody here. That's all. So my LCD is 12x. So I multiply every term by 12x. The 6 cancels out with the 12. I'm left with 2. 2 times x. 2 times 1 times x is 2x. Then here, the 4 cancels with the 12, becomes a 3, so I get plus 3x. Here, the x cancels, so I just get plus 12 equals, the 2 cancels with the 12, and I get a 6x. So 2x plus 3x plus 12 is 5x plus 12 equals 6x. Subtract the 6x, so Francisco takes 12 hours to paint a room alone. Okay. So it looks like if you're working together, you really don't want to work with Francisco because it's going to take him twice as long as it takes Sam to paint the same room. All right. Melissa walks 3 miles to the house of a friend and returns home on a bike. So one way she's walking, the other way she's riding a bike. She averages 4 miles per hour faster when cycling than when walking. And the total time for both trips is 2 hours. Find her walking speed. Well, we have to go back to our distance equals rate times time. You did this in 9th grade or in algebra, whichever it was for you, 9th grade or 8th grade. I need to figure out how long it took her, so I divide both sides by r, and I get the time equals, so I was looking for her speed, but we know the, what do we know? We know the distance, and we know it took her 2 hours in total. Sorry, so we need to get the time, or the rate, the time, sorry. So the time is equal to distance divided by the rate. So it took her 3 hours to walk there. So it's 3 hours over whatever her speed was. Plus, sorry, 3 miles. And plus 3 miles to get home over her walking rate plus 4 miles an hour, because she was 4 miles an hour faster when she's cycling. Equals the 2 hours total duration of the trip. So my LCD is r times r plus 4. So multiply everything by r times r plus 4. In the first fraction, the r's cancel out. So I'm left with 3 times r, the quantity r plus 4. In the second fraction, r plus 4 cancels out. So I'm just left with 3 times r. And on the other side, nothing cancels out. So I have 2r times r plus 4. So I need to distribute. So I have 3r plus 12 plus 3r equals 2r squared plus 8r. So 3r and 3r equals 6r plus 12 equals 2r squared plus 8. Subtract the 6r, subtract the 12. So I have 0 equals 2r squared plus 2r minus 12. They have a GCF of 2, so I cancel factored out. So I have 2 times r squared plus r minus 6. And my factors of 6 that subtract to give me 1 are 3 and negative 2. I divided by the 2 because some of you get upset when there's a number in front of is your GCF. So just dividing both sides by 2. So I'm left with r plus 3 and r minus 2 equals 0. R plus 3 equals 0 give me r equals negative 3, and r minus 2 equals 0 will give me r equals 2. I reject the negative 3 because we are talking about a rate at which somebody is moving. So the answer is just 2 miles per hour. All right, next page. All right. All right. Get back here. There you go. I need it so you can read it better. Apparently it happened. Okay. Number 3, you have 10 liters of a juice blend that is 60% juice. How many liters of pure juice need to be added in order to make a blend that is 75% juice? Well, I have 10 liters, so 0.6, 60% is 6 liters. So it's 6 liters that are pure juice out of the 10 liters that I have. And this is just like that first problem we did with tennis. We're going to add x to both the numerator and the denominator and set it equal to my percentage, which is 0.75. Multiply by common denominator, which is 10 plus x. And when I do that, I get 6 plus x equals 0.75 times 10 plus x. Distribute the 0.75. I did things a little backwards. I just subtracted the 6 first, and I got 1x equals 1.5 plus 0.75. And then I subtracted the 0.75, so I get 0.25x equals 1.5. Divide both sides by 0.25, and I get x equals 6. So we need 6 more liters to make it 75% juice. B is just like part B in that tennis problem, and I want you to try this one on your own. Write a rational equation that relates the desired percentage P to the amount of A. I used X instead of A. Of pure juice that needs to be added to make the blend that is P% juice, where 0 less than P less than 100, so P is between 0 and 100. What is a reasonable restriction on the set of possible values of P? Explain your answer. Well, we're going to use our same formula, 6 plus x over 10 plus x equals P over 100, because that's how I figured out my percent. And my restriction is I have to be between 60 and 100 for x, because I already have 60% juice, and I can't, if I'm adding pure juice to it, the amount of pure juice is not going to go down, it's going to go up, but it can't ever be 100% juice because it's already not pure. So, what's next? Suppose that you have added 15 liters of juice to the original 10 liters. What is the percentage of juice in this blend? So P over 100 is equal to 6 plus 15 over 10 plus 15. I just used our formula. And I got 21 over 25, which reduces to, when I divide out, 0.84, so it's 84% juice. So solve your equation in part C for the amount. Instead of A, we're using X. Are there any excluded values of the variable P? Does this make sense in the context of the problem? So I'd have 6 over X over 10 over X equals P over 100. And all that I had to do was solve for X. So I manipulated my formula, and I got 100 times 6 plus X equals P times 10 plus X. Distributed, so I have 600 plus 100X equals 10P plus XP. Subtract the XP and subtract the 600. I want to get all the X's on one side and all the other things on the other. So I have 100X minus XP equals 10P minus 600. Factor out an X, so I have 100 minus P equals 10P minus 600. Divide by 100 minus P, so X is equal to 10P minus 600 over 100 minus P. And are there any excluded values with the variable p? Well, it can't be equal to 100 because that will give me a 0 in the denominator, which is undefined. Does this make sense in the context of the problem? Well, of course it makes sense because we're never going to have 100% juice since we didn't start out with 100% juice to begin with. All right. You have a solution containing 10% acid and a solution containing 30% acid. How much of the 30% solution must you add to 1 liter of the 10% solution to create a mixture that is 22% acid? Well, we are going to have the 10%, which should just be 0.1, and we're only talking about a liter, so I don't have to multiply by anything. So it's just 0.1 plus 0.3A, because that's what I'm adding to it, is some amount of acid, and I'm adding a 30% acid, and then I'm going to have 1 liter plus A, because I'm adding the same amount, equals 0.22. Multiply everything by 1 plus A, so I get 0.1 equals 0.3A. 3.1 plus 3.3A equals 0.22 times 1 plus A. Distribute the 0.22 on the right hand side, and then I end up subtracting the 0.22A from both sides, and I have 0.1 plus 0.08A equals 0.22. Subtract the 0.1, so 0.08A equals 0.12, divide by 0.08, and I get 1.5 liters. Write a rational equation that relates the desired percentage P to the amount of A, 30% acid solution that needs to be added to 1 liter of 10% acid solution to make a blend that is P% acid, where P is between 0 and 100. What is a reasonable restriction on the set of possible values of P? Explain your answers. Well, we're just going to use our formula from up above and just put it equal to P over 100 because that's my percent. And my restrictions for P have to be between 10 and 30 because I already have a 10% solution, and I can't have more than a 30% solution if I'm only adding a 30% solution to it. So it's got to be somewhere between 10 and 30. All right. We're getting there. Solve your equation in part B for A. I did some magic and I got A equals 10 minus P over P minus 30. Are there any excluded values of P? Yes, it cannot be equal to 30. Does this make sense in the context of the problem? And yes, it does, because I will never have a 30% solution because I'm adding that to a 10% solution. So it's not going to ever be equal to 30%. Just like Anne, I think it was Anne, could never win 100% of the games. If you have added 30% acid solution to 1 liter of 10% acid solution to make a 26% acid solution, how much of the stronger acid did you add? Well, the A is equal to 10 minus 26 over 26 minus 30, which is just from the formula up above. So we get negative 16 over negative 4, and that is equal to 4. So you'd have to add 4 liters. All right, I think that's it. Yes, it is. So, doing it this way took me about 10 minutes less than writing it all out again. And I know I talked fast because that's just what I do. So you might have to go back and stop and pause the video, watch it, pause it, rewind it, pause it, whatever you got to do. And I will see you in class.